Welcome to GMST Davangere. I am Anil Kumar TRB, Assistant Professor, Department of Electrical and Electronics Engineering. So today we are going to study the experiment number 7. So that is the speed control of a separately excited DC motor using single phase semi-converter. So contents: aim of the experiment, theory, apparatus required, circuit diagram, procedure, calculation, results and graph. So aim is to study the speed control of circuits of separately excited DC motor using half controlled bridge rectifier, and how to plot the graph of speed versus alpha has to be determined. So here the speed of a separately excited DC motor is controlled by the varying the armature voltage using single phase semi-converter. The field winding of the motor is supplied with the constant DC source, so the field flux remains constant. The armature is fed from the single phase AC supply through a semi-converter consisting of two SCRs and two diodes. By adjusting the firing angle of the SCR using the firing circuit, the DC voltage applied to the armature can be controlled easily. So this is the actual circuit diagram. So in the circuit diagram we have the AC input from the isolation transformers. It is connected through the MCB. Then we have the two thyristors T1, T2, and we have two diodes D1 and D2. So this bridge will shows the two legs of the bridge shows it is a semi-converters, because two half SCR and half diodes we have. That is two SCR and two diodes we have. So here we have the freewheeling diodes also, and this output of this bridge is connected to the motor, and the motor is connected to the field windings for the shunt field windings for the excitations. So next we'll see the apparatus required, that is a power supply, transformers, rectifier modules, firing modules, DC motor, distributors and patch cords and CRO. Connections are made for the given circuit diagram. So field excitation will connect to the field supply. MCB switched on, the input voltage to the motor is varied by changing the triggering pulse to the SCR using the SCR. At each step the speed and the armature voltage readings should be tabulated. Note the waveforms across the SCR on the CRO and plot the graph. So these are the firing angle alpha we have taken for 180 degree. We are starting from the alpha firing to the 180 degree. This speed is 0. For 150 is 20 rpm. For 120 is 330 rpm, 90 480, 60 1775, 30 807. For 0 degree is 956. So as alpha decreases, the speed will increases. So this is actually we have to observe the waveform in the CRO. That is the input supply. Then we are again from the transformers, and this is output voltage. This you can see there is a output voltage across the CR, that is alpha to pi. Then these are the thyristor, that is T1, D1, diode D1 and thyristor will turn on during the half cycle, and remaining half cycle T2, D2 will be turned on. So the result, speed control of a separately excited DC motor using semiconductor is studied and verified. So let us see how this experiment can be conducted in a real time. Hi everyone, myself Anil Kumar TRB, Assistant Professor, Department of Electrical and Electronics Engineering. So today we are going to study the speed control of separately excited DC motor using single phase semi-converters. Our aim is to study the speed control of control circuits separately excited DC motor using half controlled bridge rectifier. So apparatus required is DC motor converter power circuits along with the firing circuits, and we have the DC shunt motor. This is the DC shunt motor. This is the DC shunt motor, and we have the isolation transformers. So these are the apparatus required. Once we turn on the circuits, we have to close the MCB switch. Then you have to turn on the module. Then, as per the connection diagrams, we have connected gate and cathode to the T1 and T2 of the thyristor, that is SCR. Then rectifier output, that is field 220 voltage DC, should be connected to the field winding of the DC shunt motor. Then across the armature should be connected across the power circuits. So this is how you have to make the circuit diagrams. So after making the connections, we have to vary the firing angle alpha. So I'll keep for the 30 degree first. Let us see what is the speed. The motor is running now. We have the speed of the motor. We need to check what is the RPM of the motor. This is 1462 for 0. Next for 60 degree. The speed is around 501. Next for 90 degree. The speed is very less. Around 168 or 72. So we have to tabulate the reading like this. So for alpha, for alpha and the speed 0 1496 for 30 degree 986 for 60 degree 850 for 90 728 120 134 150 0 and 180 degree 0 speed. Thank you.